Hello everyone, I'm Alpay, a master student at Koç University and a research engineer in Twin Science and Robotics. Actually, I'm a second year student, and Twin is a 2-year-old startup, and I am trying to integrate the research culture into the company. And we are open to any contribution and feedback. In this talk, I will be presenting to you our design process of 1-year curriculum to teach artificial intelligence for middle school students. So why did we develop this curriculum? The reasons behind developing this curriculum can be summarized with 3. The first one is AI has become a common ingredient in everyday products and a part of early education. So we should inform students about its benefits and risks. The second reason is educators want to teach the subject to inform students about AI, but cannot pick reliable sources. And the last one is teaching about AI is a good way to discuss the potential benefits and risks of developing a new technology. So we aim to, after completing this curriculum, the students will be able to learn about blockchain or electric motors in a meaningful way, like any other new technology. Our contribution to the education community with this research can be listed with, again, 3 reasons. We provided interdisciplinary connections to better understand the science behind developing a new technology. The second one is there is a wide variety of interactive resources that we can utilize to teach about sensors, the working principles of the algorithms using data, or the societal impacts of AI. We structured these recent resources to ease the integration of AI into classrooms and guide teachers. And the last one is the educational content should be accessible to everyone. So we created unplugged and plugged resources that can be used to teach the same topic with or without computers. So our approach, we put Turisky's 5 big principles into the core of the curriculum. It is also open source. You can take a look at the GitHub wiki of Turisky's repo. These principles help us to find the appropriate content while designing the modules and form smooth transitions between subjects. To create a meaningful learning experience, we examined some of the most used coding curricula first and built content around students' previous knowledge. Grasping the AI concepts requires an overall understanding of interdisciplinary subjects like mathematics, coding, linguistics, sociology, or statistics. However, most teachers struggle with bringing all the resources from different disciplines into their class hours. To overcome this struggle, we partnered with teachers from the early phases of the curriculum development process. Before proceeding with the details of the modules, let's see some of the previous efforts on teaching AI in K-12 education. Robotic learning kits to introduce AI concepts has become more accessible with the decreasing price of do-it-yourself kits, like Cosmo and Google's do-it-yourself AI. Recently, MIT Open Learning launched a new website that brings various groups from MIT together to make their content easy to find. Although their content varies from kindergarten to high school, in the middle school years, we can use Cognimates and AI modules of the App Inventor. We also included unplugged activities from MIT's ethical AI curriculum and CS Unplugged. So in the design process, we got constant feedback from teachers. Actually, we are still actively communicating with half of the teachers in our messaging group. In the beginning, we started to discuss AI content with teachers by designing these workshops. In the design process, we showed example contents and tried to understand the positive and negative sides. The teacher's common view on the provided content is the lack of explanation of AI concepts and the disorganized structure of the activities. We designed new worksheets that combine physical and digital experiences in a structured way. And in our workshop, the most engaging moment was these worksheets that utilize the digital content to fill in the blanks or complete a task on the worksheet, as you see in the figure. In the workshops and later in the online lectures, we use tools like Mentimeter and Kahoot to make the lectures more interactive. We offered explorable explanations. It's informative media that the readers can explore the reading content playfully and promotes an active form of reading and listening. We also selected contents from Google AI experiments and similar website to support explorable reading activities. So, module 0. We start with the questions like, what do you know about AI? Where do we see AI? What are the differences between a standard algorithm and an AI algorithm? In each module, we try to engage students with fun and unplugged activities. For example, in one of the workshops, teachers offered to do the paper plane activity. We can adapt this activity for different kinds of exercises, actually. In each round, students write an AI application on the paper plane, through the paper plane to each other, pick, read, and continue this cycle. We also use teachable machine and teachable arcade, as you see in the GIF, in the introduction to quickly show an end product of AI. The introduction took 3 class hours, and the next module is intelligent user interfaces. It becomes the bridge between the old coding knowledge and new AI concepts. The history of intelligent interaction can be interpreted as a good summary of the history of computer science. The module also introduced how can we design new products with the design thinking method. Students use prototyping tools and techniques to design an interface, then learn how others make their products smarter. The second and largest module, how do computers see, takes 15 class hours. This module takes this time because it has the widest application area and has lots of interesting resources. The module completes the full cycle of Turesky's 5 big ideas. Students create a camera obscura to better understand the working mechanism of digital cameras. Then they read unexplorable explanations to compare the camera with our eyes. Learn about pixels, how to manipulate pixels with algorithms, then learn about how AI algorithms differ from a standard algorithm and why learning from data works in AI algorithms. In the end, we discussed the cases from Beijing City, how facial recognition technology is used by the government, and read different articles from the Chinese media or other media. After the computer vision module, speech recognition and natural language processing is discussed with completing Turesky's cycle. We try to answer how computers hear and communicate with us in our language. And after completing these 2 modules, we aim to make students answer questions like, how can computers smell things? Like, how can we develop new technologies like this? All modules have lots of integrated interactive web content, like the interactive reading on the eye, edge detection algorithms, sound analysis. Additionally, we use game-like AI-supported activities like Quick Draw. Actually, using Quick Draw to teach about learning from data was one of the best practices in our workshops. We had the chance to talk about how students' drawings are recognized in a single line of drawing, or how the machine could not predict, although students have drawn a detailed sketch and human could easily predict their drawing. We prepared small code quizzes for each lecture, but to assess their learning at the end of the semester, we prepared a form to propose an AI project on sustainable development goals. In the form, we expect them to choose sensors, structure an algorithm, pick appropriate data, and predict some possible advantages and disadvantages beforehand. In the meetings with teachers, some of them assert that parents want to see tangible outcomes at the end of every class. Therefore, these teachers state that they do not want to spend time with background knowledge because it would not produce tangible outputs. They want to show tangible outputs. They mostly want to code and show a visible output at the end. However, there is no easy coding platform for middle school students to code AI. As seen in the figure, this figure, notebook-like environments are easy to use, show real-time output, and can be adapted to middle school student use. But it requires another research to select and create the best environment for AI coding. Another challenge that appears in the design of the workshop is to organize teachers from different disciplines to work together while integrating the curriculum. And preparing the vision and speech modules interchangeable was a primitive decision to make the curriculum accessible to everyone, but we did not focus on physical accessibility in this current research. And the last slide, future work. For the future work, our first goal is to make the content accessible to everyone. We were planning to conduct longitudinal research with public and private schools this semester. However, due to this pandemic, we postponed them to next semester. Additionally, we want teachers to be partners in the design phase, similar to the participatory design process, and explore the teacher-teacher and teacher curriculum designer collaboration. I can take questions. Thank you.